Hi, this is Robert Rapier, and this is R Squared Energy TV. On this week's episode, I've got questions about the use of rare earth elements in the production of renewable energy, and then I've got some questions on pyrolysis soil. So the first question, can you discuss the uses of rare earth elements in the production of renewable energies such as wind and solar power? Further, can you comment on the supply of rare earth elements? I recently watched a video, and I'll link to it, and it says, is it accurate that China controls 97% of current supplies? What implication does this have on the growth of hybrid transportation, wind and solar, etc.? That's correct. This is one of those trade-offs that you get into with renewable energy that we don't often think about. So, one of the things I like to talk about is making sure that we really understand the trade-offs we're making over our various energy sources. If we look at nuclear power, what's the trade-off? If we look at wind power, what's the trade-off? And some people don't realize there are actual trade-offs. In this particular case, the wind turbines, the gears, they use these rare earth elements that come from China. And China has the vast majority of the world's supply, and have been restricting the exports. Now, there is a mine, I believe, in the U.S., but we don't have a lot of that. We don't have a lot of rare earth mining. We could expand that. There could be replacements. I don't know the status of various possible replacements of those rare earth elements, but we're in a situation right now where China not only is they're growing oil production, helping drive oil prices up, but this situation here, they have a very large sway over what's going to happen in renewable energy because of their domination of the global rare earth supply. It's not only rare earths either. Lithium, for instance, is not a rare earth element, but Bolivia controls the world's lithium supply, and lithium is critical for lithium-ion batteries. So, we're all keenly aware of dependence on OPEC for oil, but we may be less aware that we could be trading away that dependence for another dependence on something else. And as I say, maybe that's an okay trade-off. For instance, I would ethanol from Brazil I think is fine. I think Brazil is a good stable trading partner, and they make their ethanol efficiently. So that's a kind of trade-off that maybe is not so bad. When we trade off with dependence on countries that are maybe hostile to our interests, maybe that's not such a good trade-off. So it's just one of those things where we need to be aware, we need to be looking for substitutes for these rare earth elements and trying to the extent we can to develop them ourselves. Second question, I was watching your reports and was wondering your opinion about the feasibility of pyrolysis. I've seen a lot of companies advertising they can take plastic or tires and produce 80% or 45% pyrolysis oil. Is that accurate? You also mentioned upgrading of pyrolysis oil. Are there any companies out there who can do it on a commercially viable process? If so, could you point me in the right direction? So pyrolysis is just the rapid heating of material. I generally think about biomass, but it's true. You can do it with plastics or tires, and it cracks the molecules. So plastics are very long chain hydrocarbons, polymers, and when you heat them up very rapidly, it can crack those into shorter chain hydrocarbons that could ultimately be used for fuel. When you pyrolyze wood, it unravels the complex molecules in the wood and makes shorter chain, not hydrocarbons, but oxygenated, things like acids and ketones. And it's a pretty nasty mix. It's not really a fuel that you would use in a diesel. It can be used in a boiler, but it's corrosive and it's not very stable. But it is true, it can be upgraded. And one of the companies that's been working on this for a long time has made pyrolysis oil. It's called Ensign. And I visited them in Canada. They've got a plant up there. I think it's 100 tons a day of wood that they bring through and they convert into pyrolysis oil. Now they formed a joint venture with UOP called Invergent. And that is for the purpose of taking pyrolysis oil and upgrading it and making fuel out of it. And so they are in an agreement with Tesoro over in Honolulu, and they're building a small demonstration pyrolysis oil to fuel plant. And they've gotten I believe it's a DOE grant, I think $25 million to help build that plant. The technology for upgrading pyrolysis oil, UOP does upgrading technologies. That's Honeywell's UOP, does upgrading technologies for refineries, and they are the ones that are doing this technology to upgrade the pyrolysis oil. It's been done. It's not pie in the sky. It actually can be done. There are papers on it, what the yields are, and so forth. The only question is, can it be done economically? Because a lot of the pyrolysis oil is lost to carbon dioxide or water whenever it's upgraded. But absolutely, it's technically feasible. I think the biggest question is going to be whether it's economical, and I think we'll find that out over the next few years. So with that, that's this week's episode. Please tune in next week. Thank you.